Hello children, welcome to the digital class. In your last session, you learnt about measures of central tendency, which are mean, median and mode. In this session, you are going to learn how to prepare a frequency distribution table when a raw data is given and how to draw graphs for a given frequency distribution. Okay children, now observe the screen. It is a classroom. Grades with number of students in a FA are as follows. Children, this is the raw data. How can we represent this raw data in the form of table? Let us understand. Children, like this we can represent the previous raw data in the form of frequency distribution table. Now, can we represent the same using a graph? Yes, I am using here bar graph. Children, this is a graph paper. This is x axis, this is y axis. Now, A1 is 9. So, A1 is 9. I have taken on y axis 1 unit equal to 2 students. So, 2, 4, 6, 8, 10. What is the number of students for A1 grade? Yes, it is 9 students. So, 9 will come between 10 and 8. Next, A2, 10 students. B1, 11 students. B2, 8 students. C1, 7 students, C2 5 students. Children, like this you can represent the given data using frequency distribution table as well as graph. Now, let us know the learning objectives of this session. You will be able to know cumulative frequency of two types, greater than cumulative frequency and less than cumulative frequency. Graphical representation of data, in which you are going to learn histogram, frequency polygon and frequency curve, graphs of cumulative frequency distribution. Okay children, now observe the screen. It is a school building. Here there is an examination on a day and 30 classrooms were filled with students. So, number of students in 30 classrooms are given below and you have to construct a frequency distribution table. See children, 25 students are there in room 1, 30 students are there in room 2, 24 students are there in room 3. Like this, number of students in each room is given up to 30th room. Now, what we have to do? We have to prepare frequency distribution table. First, we have to find range. Children, what is range? Yes, it is a difference between maximum value and minimum value. So, I can say range equal to maximum value minus minimum value. 40 is the maximum value and 15 is the minimum value. So, what we can do here? 40 minus 15. Children, what is 40 minus 15? Yes, it is 25. Now, class interval is taken as 4. In the question they ask you to take class interval as 4. So, here we are taking class interval as 4. How to find number of classes? Yes, it is range by class interval. What is range? It is 25 divided by 4. When we cancel this, what you will get? 4 ones, 4, 6.25, you will get 7. See children, here we have to take the next integer. So, the next integer of 6.25 is 7. Now, tell me how many classes we will get here? Yes, we will get 7 classes. Now, in this one, which is the least value? Yes, it is 15. So, we have to start taking from 15. And what is the size of the class or class interval? Yes, it is 4. So, what you have to do? You have to add 15 with 4. So, what will get? 19. So, the first class is 15 to 19. Again add 4 to 19, you will get 19 to 23. Next 23 to 27, 27 to 31, 31 to 35, 35 to 39, 39 to 43. Children, here we are getting 7 classes, 1, 2, 3, 4, 5, 6, 7 and the highest value must come in the last class. Are you able to get this 40? Yes. Now, what to do? You have to prepare tally marks. How? What is the first number? 25. See children, I am cancelling 25 here. Now, tell me where the 25 will come? Yes, in 23 to 27 class. So, I am taking one line here. Now, 30, where this 30 will come? Yes, in 27 to 31 class. Next 24, where it will come? In 23 to 27 class. Next 18, where it will come? Yes, in the first class, that is 15 to 19. 21 where it will come? Yes, in the second class 19 to 23. Next 24 where it will come? Yes, in 23 to 27 class. Children, like this you have to cancel each number and you have to take its tally mark in the frequency distribution table. Now, if you proceed like this, what you will get? For the first class you will get 5. For the second class you will get 5 plus 2, 7. Children, how to represent 5 here? It is very simple. Take 4 vertical lines and draw one line cross, or we can say diagonally, so that I can say that it is equal to 5. Cross the 4 lines, so that we will get 5. Here also 5 plus 2 which is equal to 7. Next 5 plus 1, 6. Next 5, 5, 1, 1. Children, like this you can prepare frequency distribution table for a given raw data, and the total must be equal to 30. Why? Because we are taking 30 classrooms, so the total frequency must be equal to 30. From this what we can understand? There are classrooms which are having 15 to 19 students. Can you tell me the number of rooms which are having students 15 to 19? Yes, 5 rooms. Can you tell the number of rooms which are having students between 39 to 43? Yes, only 1 room. Like this we can prepare frequency distribution table for a given raw data. Okay children, now what you are going to do? A grouped frequency distribution table is given below with class mark, or we can say mid values of class intervals and frequencies. Now we have to find the class intervals. How to do that? Let us check. See, these are the class marks and this is the frequency. Children, what are class marks? Yes, these are mid values. Now here class intervals are not given. What are given? Mid values are given. So what you have to find now? You have to find the classes, or we can say class intervals. How to do that? Let us check. In the given frequency distribution table, class marks. See children, these are the class marks. What are the class marks here? 7, 15, 23, 31, 39 and 47. Now what you have to do? You have to find the difference between two successive class marks. See, like this you can find 15 minus 7, or you can find 23 minus 15, or you can find 31 minus 23 and so on. So here what I am doing? I am taking 15 minus 7. 15 minus 7 equal to 8. Now the lower boundary and upper boundary of every class will be x minus h by 2 and x plus h by 2. So lower boundary is x minus h by 2. Upper boundary is x plus h by 2. What is x? Yes, it is class mark. Children, what is h here? 8. If I take h by 2, what I will get? 8 by 2 which is equal to 4. So like this we can prepare frequency distribution table. Now class marks, class intervals, frequency. First class mark is 7. So what I have to do? 7 minus 4, 2, 7 plus 4. What is 7 minus 4? Yes, it is 3. 7 plus 4, 11. Next 15 is the class mark. So what you have to do? 15 minus 4, 2, 15 plus 4. So I can say 15 minus 4 is 11, 15 plus 4 is 19, 11 to 19. Like this we will get the third class as 19 to 27, fourth class as 27 to 35, fifth class as 35 to 43 and sixth class as 43 to 51. So children, what you are getting here? Yes, we are getting class intervals. In this question, class marks are given. We are finding class intervals. How to find the class intervals? Understood children? Yes. Now here marks of 50 students in a FA out of 20 marks are given. Can you answer this question children? Find the number of students who got 1 to 5 marks. Yes, 6 students. Find the number of students who got 16 to 20 marks. Yes, 9 students. Can you find the number of students who got more than 10 marks? Children, using this table, can you find the number of students who got more than 10 marks? Is it possible? Can you find the number of students who got less than 10 marks? Is it possible using this frequency distribution table? No, it is not possible. So what we need to find these answers? Yes, we need cumulative frequency. So cumulative frequency is of two types, that is LCF and GCF. Now let us understand what is less than cumulative frequency. The progressive total of frequencies from first class to the upper boundary of last class is called LCF, or we can call less than cumulative frequency. Now children, I am taking a question here. Construct less than cumulative frequency table for the following data. What is the data here? Yes, this is marks, these are frequencies. Now we have here 4 classes and we have 4 frequencies. Now what we have to do here? We have to prepare less than cumulative frequency distribution. Okay children, now what I am doing here? First I am taking class interval. next upper boundary, next frequency, next LCF. First class interval is 0 to 5. For this 0 to 5, 5 to 10, 10 to 15, 15 to 20. Children, in your last class you learnt what are exclusive classes, right? So these are exclusive classes. For exclusive classes, boundaries and limits are the same. So 5 is the upper boundary, 10 is the upper boundary, 15 is the upper boundary, and 20 is the upper boundary. So what I am doing here, I am taking 4 upper boundaries of 4 classes. Next frequencies I am taking as it is 6, 15, 18, 7. Now how to find LCF? It's very simple. Take the first frequency. What is the first frequency here? Yes, it is 6. Next 6 plus next frequency. What is the next frequency? 15. 6 plus 15. Children, what is 6 plus 15? Yes, it is 21. Now 21 plus 18, which is equal to 39. 39 plus 7, which is equal to 46. Can you find the number of students who got less than 10 marks here, students? Yes, where you are getting upper boundary here? Yes, it is 10. Now can you tell me the LCF of this? Yes, it is 21. So from this what we can understand? Number of students who got less than 10 marks is 21 students. See children, when you want to find something which is less than, then you have to use less than cumulative frequency table. Here what is the question? Find the number of students who got less than 10 marks. So what you have to do? This 10 you have to check in upper boundary and you have to take its corresponding LCF. So what is its corresponding LCF? 21. So 21 students got less than 10 marks. Now let us understand what is greater than cumulative frequency. The progressive total of frequencies from last class to the lower boundary of first class. Children, let us construct a greater than cumulative frequency distribution for the data. Here also I am taking the same table. Now I am taking class interval, lower boundary, frequency, GCF. See children, for LCF we have to take upper boundary, for GCF we have to take lower boundary. Now what I am doing, I am taking the classes here. First class 0 to 5, second class 5 to 10, third class 10 to 15, fourth class 15 to 20. Now we have to find lower boundaries. So what is the lower boundary? 0 here, 5, next 10, next 15. So what I am doing here, I am finding the lower boundaries. Why I am taking the same values here? As the classes are exclusive, boundaries and limits are the same. Now these are the frequencies. Now what I am doing to find GCF, I am taking the last frequency. Children, what is the last frequency here? Yes, it is 7. Now what you have to do? 7 should be added with 18. So what is 7 plus 18? 25. Now this 25 should be added to 15, we will get 40, and 40 should be added with 6, we will get 46. Children, in LCF we are adding from first frequency to last frequency progressively. Here in GCF we are adding from last frequency to first frequency progressively. So we are calling it as greater than cumulative frequency table. Now can you find the number of students who got more than 5 marks? Children, if there is a question to find less than, we have to use LCF table. If there is a question to find more than, we have to use GCF table. Now find the number of students who got more than 5 marks. Children, where is 5 in lower boundary? Yes, here it is. And what is the corresponding GCF for this? Yes, it is 40. So now tell me, how many students got more than 5 marks? Yes, 40 students got more than 5 marks. So children, using this LCF and GCF, we can find the number of students who will get less than or more than a given mark. Now let us understand graphical representation of data. In that, first I am considering bar graph. Children, what is bar graph? Yes, a display of information using vertical or horizontal bars of uniform width and different lengths. Try to understand children here, width must be same but length will be varying. Now I am taking a bar graph here. Children, what is this bar graph? Is it a vertical bar graph or horizontal bar graph which you have studied in your lower classes? Yes, it is a vertical bar graph. Now I am using bar graph to answer some questions here. Can you find the number of students who got B1 grade? Children, check the bar graph and tell me the number of students who got B1 grade. Yes, here it is B1 and the length is showing how much? 10 on y axis. So I can say 10 students got B1 grade. Find the number of students who got A1 grade. Children, can you find it? Yes, this is the A1 and you can see that its corresponding number here, it is 6. So 6 students got A1 grade. So this is called interpretation of a graph. Children, using this graph we are able to answer questions. Graphical representation of grouped frequency distribution. Children, in that first we are going to learn about histogram. What is a histogram? Yes, a graphical representation of frequency distribution of exclusive class intervals with the help of bars. Children, we cannot construct histogram for inclusive classes. We have to construct histogram for exclusive classes. Suppose if I want to construct histogram for inclusive classes, what we have to do? We have to convert them into exclusive classes first, then we have to go for histogram. And here bars are nothing but the rectangles. A histogram consists of bars. Children, try to understand here. A histogram consists of bars. Bars are nothing but rectangles. Lengths of bars represent frequencies of class intervals. Widths of bars represent sizes of classes. Heights of bars are proportional to the frequencies. There are no gaps between the bars in a histogram. Children, in a bar graph you can find gaps between the rectangles, but in histogram we should not find any gap between the rectangles, or we can say bars. So we can say there are no gaps between the bars in a histogram. Histogram with same base widths. Children, here I am constructing a histogram for a given data. Here 0 to 5 is the first class, 5 to 10 second class, 10 to 15 third class, 15 to 20 fourth class. Here all classes are having same size, or we can say widths are same. Now what you have to do? Yes, I am taking a graph paper here. I am drawing x-axis, I am drawing y-axis. I am taking the scale here. Children, try to understand. On x-axis 1 centimeter equal to 5 marks. On y-axis 1 centimeter equal to 5 students. So first I am taking 0, next 5, 10, 15, 20. On y-axis also same 5, 10, 15, 20. Okay children, where is the first class here? 0 to 5. Yes, here is the first class. Now what I am doing? I am taking a rectangle, and what is this value representing? Yes, it is 6. Children, 1 centimeter equal to 5. Then the second line will become 6. 5 to 10, 15, here we can take as it is here, 15 is the direct number, right? So 5 to 10 class is having 15 frequency. Next 10 to 15 is having 18. How to take this 18 children? After 15, 6th line. Next 15 to 20 is 7. Children, how to take 7? After 5, 4th line. If it is 6, after 5, second line. If it is 7, after 5, 4th line. What you are seeing on the graph paper children? Yes, rectangles, and we can call it as a histogram. Like this you have to construct histogram for a given frequency distribution table. Histogram with varying base widths. Children, here I am considering a histogram which is having different classes, or we can say sizes of classes are different. Children, you can understand here 0 to 35 marks failed, 35 to 50 marks third class, 50 to 60 marks second class, 60 to 100 first class. Here the size is 35, here it is 15, here it is 10, here it is 40. Are you finding the same sizes here? No. So we are calling them as varying base widths. Now when you get this kind of distribution, what you have to do children? Yes, we have to find density. How to find density? Frequency of class by length of that class into least class length. Now I am preparing the frequency distribution table here first for the histogram. Yes, it is 0 to 35, next 35 to 50, 50 to 60, 60 to 100. Children, here I am taking as it is. Now I have to find length of the bar. How to find length of the bar? First 28 divided by 35 into what is the least class length here? Yes, it is 10. So 28 by 35 into 10. After cancellation, what you will get? You will get 8. Next 12 by 15 into 10. 12 by 15 into least class length, that is 10. After cancellation, you will get 8. Now third 16 divided by 10 into 10. Children, here 10 will cancel, you will get 16. Now 44 by 40 into 10, after cancellation you will get 11. Children, here I am finding the length of the bars. If you get classes with different class sizes, then you have to find the density. So density gives the length of the bar. So I am finding the density here, which is equal to 8, 8, 16, 11. Now I have to draw histogram for this. I am taking x-axis, y-axis, scale. x axis 1 centimeter equal to 20 marks. So, 0, first 20, 40, 60, 80, 100. On y axis 1 centimeter equal to 5% students. So, 5, 10, 15, 20. Now, 0 to 35, what is the frequency children? 8, yes. So, here 8 means after 5, 6th line. So, I am taking here 6th line. So, 0 to 35, children try to understand here, 20 to 40 middle you will get 30, 30 to 40 middle you will get 35. So, from 0 to 35 I am taking frequency as 8. Next 35 to 50, children this is 35 and here between 40 and 60 you will get 50. So, 35 to 50 frequency is also 8. Next 50 to 60, this is 50, 60, 50 to 60 the length is 16. How to take 16 children? After 15 second line. Now 60 to 100 is 11, 60 to 100 is 11 means after 10 second line. Children, are you observing here bars with different widths? Yes, this is a histogram, okay, with different. Now let us understand what is a frequency polygon. A graphical representation of a frequency distribution, either it is discrete or continuous, means inclusive classes or exclusive classes. In frequency polygon, class marks are taken on x axis and their corresponding frequencies on the y axis. Try to understand this children. In frequency polygon, class marks are taken on x axis and their corresponding frequencies on the y axis. Area of frequency polygon and histogram drawn for the same data are equal. Okay children, now I am constructing frequency polygon using a histogram. This is the histogram already we constructed. Now how to draw frequency polygon for this? Let us understand. First, I have to take the middle point of the top of the bar, middle point of the top of the bar. Okay. Next, I am taking the point as B, second middle point C, third middle point D, fourth middle point E. See children, here we have 4 bars. So, I am finding the middle point of the top as B here, C, D, E. Now, what you have to do? You have to join them so that you will get a frequency polygon. Now, what you have to do after this? 0 to 5 is the first class, 15 to 20 is the last class. Now, what you have to do? You have to take the midpoint of the next class and here midpoint of the previous class. So, I am taking midpoint of the previous class as A, midpoint of the next class as F. Now, what I am doing here children? I am joining BA, I am joining EF. Now, I can say that A, B, C, D, E, F is a frequency polygon, and mathematically I can say that this frequency polygon and histogram having same area because they are constructed for the same data. So, using histogram like this we have to construct a frequency polygon. Area of frequency polygon and histogram are equal for this data. For the same data, when they are constructed, their areas will be equal. Frequency polygon without using a histogram. Let us construct a frequency polygon for the following data. See children, here ages are given and number of teachers are given, 24 to 28, 28 to 32, 32 to 36, 36 to 40, and the frequencies are 12, 10, 15, 9. Now, I am preparing frequency distribution table with mid values. Class intervals, frequency, mid values, and we are taking the point. First, 24 to 28, frequency is 12. So, children, how to find the mid value for this? It is very simple. 24 plus 28, you will get 52. 52 by 2, you will get 26. So, mid value for 24 to 28 class is 26. And how to find the point here? Mid value is taken as x, frequency is taken as f. So, x comma f. Try to understand this children. X comma f. X is 26, f is 12. So, 26 comma 12 is the point. Now, I am taking the second one here, 28 to 32, mid value is 30 and the point is 30 comma 10. Third one, 32 to 36, mid value 34, the point is 34 comma 15. Fourth is 36 to 40, mid value is 38 and the point is 38 comma 9. Using these points, we have to construct the frequency polygon. Children, I am using the points here, I am taking a graph, okay. I am taking the x axis and y axis here. Children, can you find a symbol here? Why I am using this symbol? Yes, we are starting with the 26. So, if I take 0 to 4, 4 to 8, 8 to 12 and so on, I need a long graph paper, right, lengthy graph paper. To avoid that, what I am using a continuation symbol here. So, if you use this symbol directly, we can start with the first one. So, this is the symbol used to start with a required number on x axis. So, I am taking x axis, y axis and scale. On x axis 1 centimeter equal to 4 years, on y axis 1 centimeter equal to 5 teachers. 0. See children, here directly after 0 I am taking 24, I am not taking 4, I am taking 24 because I am using the symbol here. So, 24, 28, 32, 36, 40, 44. On y axis 1 centimeter equal to 5 teachers. So, 5, 10, 15, 20, 25. Okay children, now what is the first point here? 26, 12. See children, where you will get 26 here? Yes, between 24 and 28, where you will get 26. And where you will get 12? Yes, after 10th, 4th line. So, where these two intersect? This is the 26 and this is the 12. So, where these two intersect? Yes, here. So, 24 to 28 between point 26, after 10, 4th line 12. Next point 32, I am taking the point as B here. Next point 30, 10. Next point 34, 15. Next point 38, 9. See children, here we have 4 points. I am taking 4 points here. I am naming the points as B, C, D, E. Now, what you have to do children? You have to join them. I am joining B, C, C, D, D, E. Next, what you have to do? Yes, we have to take the midpoint of the previous class. I am getting here. I am naming it as A. I am taking the midpoint of the next class. So, I am taking the point as F. Now, I am joining AB, I am joining EF. So, I can say ABCD EF is a polygon. Children, what is this ABCD EF? Yes, it is a polygon. Here we constructed polygon without using histogram. What is this children? Yes, it is a frequency polygon. Now, let us understand what is a frequency curve. A graphical representation of a frequency distribution by a freehand curve. See children, in frequency polygon we are joining points with straight lines. Here we have to join by freehand curve. I am taking a question here 2.5, 6. So, where this 2.5 will come? Yes, between 0 to 5, 2.5, 6 after 5, second line. So, I am getting the point here. Next 7.5, I am taking the first point as B. Second point 7.5, 15, 7.5 will be between 5 to 10. Yes, you will get 15 direct. I am taking the point as C. Next point 12.5, 18, 12.5 will be between 10 to 15. Here we will get, and 18 after 15, sixth line. Okay, I am getting here. I am taking the point as D. I am next 17.5, 7. 17.5 will be between 15 to 20 and 7 will be after 5, fourth line. Now, I am getting here 4 points. What are the 4 points children? B, C, D, E. Now, I am joining by freehand curve. Again, previous class mid value, last class next mid value. I am taking A, F, I am joining and I am getting frequency curve here. A, B, C, D, E, F is the frequency curve. Let us understand cumulative frequency curve, or we can say OG curve. A graph representing the cumulative frequencies of a grouped frequency distribution against the corresponding lower upper boundaries of respective class intervals. We have two types of cumulative frequency curves. First one, less than cumulative frequency curve. Second one, greater than cumulative frequency curve. Children, what is cumulative frequency curve here? We have to draw a curve using lower or upper boundaries and their corresponding cumulative frequencies. First, let us understand what is less than cumulative frequency curve. Here, upper boundaries are taken on x-axis and their corresponding less than cumulative frequencies are taken on y-axis. Greater than cumulative frequency curve. Here, lower boundaries are taken on x-axis and their corresponding greater than cumulative frequencies are taken on y-axis. Let us construct LCF and GCF curve for the number of tenders received by a department from the contractors for a civil work in a course of time. Okay children, here days 0 to 4, 4 to 8, 8 to 12, 12 to 16 are given and the number of tenders we got between 0 to 4 days is 5, next to 12, 15, 8. Now, for this data we have to construct LCF and GCF distribution table first. So, days, number of tenders, upper boundary, LCF, lower boundary, GCF. For LCF we have to take upper boundary, for GCF we have to take lower boundary. Okay children, the first class is 0 to 4, number of tenders 5, upper boundary 4, 4 to 8, upper boundary 8, 8 to 12, upper boundary 12, 12 to 16, upper boundary 16. As these are exclusive classes, limits and boundaries are the same. So, upper boundaries are 4, 8, 12, 16. And children, how we got this LCF? It's very simple. First one is 5, first frequency, 5 plus 12, 17, 17 plus 15, 32, 32 plus 8, 40. Like this we have to prepare LCF. Now, how to prepare GCF? Yes, lower boundary of last class is 12 and frequency is 8. Next 8, 23, 4, 35, 0, 40. 8 plus 15, 23, 23 plus 12, 35, 35 plus 5, 40. So, this is the LCF and GCF distribution, and for this let us draw the graph. I am taking here point for LCF and point for GCF. X axis, y axis I am taking here scale. On x axis 1 centimeter equal to 4 days, on y axis 1 centimeter equal to 10 tenders. Okay children, now 0, 4, 8, 12, 16, 20, 4 multiples. 0, 10, 20, 30, 40, 50, 10 multiples. Now what is the first point here? Yes, it is 4, 5. Next point 8, 17. 8, 17. 17 will be after 10, 7th line. So here is the point. The first point is named as A and the second point is named as B. Third point 12, 32. 12 is here, 32 after 30, second line. Next fourth point 16, 40. The point is taken as D here. Now what I am doing? I am joining A, B, C, D. So I am getting a curve here. This curve is called LCF curve. So like this we have to draw LCF curve for a given distribution. Now let us draw GCF. First point 0 to 40, this is 0, this is 40. I am taking the first point as E. Second point 4, 35. Third point 8, 23. Fourth point 12, 8. So I am naming the points as E, F, G, H. So now I am joining them by a freehand curve. So I am getting like this: E, F, G, H is joined with 16. I am calling the curve as GCF curve. Children, like this we have to construct LCF and GCF curves for a given frequency distribution. Children, try yourself. Construct a histogram for the following data. Marks and number of students are given here. Marks 0 to 10, 10 to 20, 20 to 30, 30 to 40. Frequencies or number of students are 8, 12, 10, 5. Construct a frequency polygon for the following data. Wages and number of workers are given: 300 to 350, 350 to 400, 400 to 450, 450 to 500, and number of workers or frequencies given as 15, 20, 25, 10. Okay children, for better understanding of the concepts, solve the worksheets. Please visit the official website of SCRT for worksheets. Let us meet in our next section. Thank you.